Hello friends, welcome back to my channel. Light is a form of energy. We are able to see the things around us with the help of light. That means in the presence of light, things are visible to us. So in this video, we shall learn about few properties of light which is given in the syllabus of Gpstr exam 2022. Before moving to the video, if your video quality is of auto quality, please set into the high resolution, that is 1080p, so that you will get the clear view of the images. We shall move to the topic now. Speed of light in vacuum is 3 into 10 to the power of 8 meter per second, we all know. And light possesses properties like reflection, refraction, diffraction, interference, polarization, dispersion and scattering. These are the very important properties of light. In the syllabus, we have to learn about reflection, refraction and scattering of light for the exam 2022 of Gpstr exam. The remaining properties also we will discuss later, which will be useful for the following exams like TET, Central TET also. Let's move to the topic now, reflection of light. The return of light into the same medium after striking a surface is called reflection. It's the reflection of light which enables us to see the different objects around us, right? And I'm not moving in depth into the basics. I hope we all know the basics of this, would have learnt already. So we will move to the main points related to the exams now. There are two types of reflection, regular reflection and irregular reflection. Whereas regular reflection means when light falls on a smooth surface, we get a regular reflection. When a light falls on a irregular surface, a rough surface, we get irregular reflection. It's a diffuse light obtained by the reflection from the uneven surfaces which enable us to see the objects around us. Okay. So in this image, we can observe regular reflection and irregular reflection. So when light falls on a smooth surface, it is reflected back to the same medium evenly. So this is the regular reflection. In case of an irregular reflection, the light falls on a irregular surface or a rough surface, and you see the reflected light in this form. Now let us learn few important terms related to reflection of light. So in this topic, we will be learning about reflection at plane surfaces, especially on the plane mirror reflection. So we'll be showing the image in case of plane mirror reflection only here. It's understood throughout the chapter we carry this concept. Incident ray. The light ray striking a reflecting surface is called the incident ray. In this image we can observe incident ray which falls on a smooth surface and which is reflected back like this. Incident ray, if you take this as A, P is the incident ray. The ray which is incident on the reflecting surface is called as incident ray. Point of incidence. The point at which the incident ray strikes the reflecting surface is called as point of incidence. In this image, at point P, the incident ray strikes the reflecting surface. So here P is the point of incidence. Next, reflected ray. The light ray obtained after reflection from the surface in the same medium in which the incident ray is traveling is called as reflected ray. In this image, at point of incidence P, the light ray strikes the surface and it is reflected back to the same medium as reflected ray. So this is the reflected ray. The light ray, after striking the reflecting surface and return back to the same medium, is known as reflected ray. Next is normal. The perpendicular line, a perpendicular drawn to the surface at point of incidence, is called as normal. So here this line represents the normal, which is drawn perpendicular to the surface. So this is a smooth surface. Perpendicular means 90 degree. It is represented by dotted line here. So this is the normal line which is drawn. The line which is perpendicular to the reflecting surface is known as normal. So here we can observe angle I here. The angle made by the incident ray at point of incidence with normal. This is the angle of incidence or incident angle I. Next is angle of reflection. It is represented by letter R. The angle with the reflected ray makes with the normal at the point of incidence is known as angle of reflection. Next is angle of incidence or incident angle. We can also call it as. It is represented by small letter I. In this chapter we represent like this only, angle of incidence as small letter I. The angle which the incident ray makes with the normal at the point of incidence is called as angle of incidence. In this diagram you see the angle is formed between normal and the reflected ray at the point of incidence. So this is reflected ray R. Next is plane of incidence. The plane containing the reflected ray and normal is called as plane of incidence. Meanwhile, we'll check out with plane of reflection also. The plane containing reflected ray and normal is known as plane of reflection. So in this image, this is the plane of incidence. This plane is a plane of incidence, and the other side, this is the plane of reflection. The angle made with the incident ray with normal at the surface, this surface is called as plane surface, is plane of incidence. The other side of the plane with the reflected ray and the normal. So this plane is plane of reflection. Next we shall move to an important concept, laws of reflection. The angle of incidence I is equal to the angle of reflection. This is the first law of reflection. I repeat, the angle of incidence I is equal to angle of reflection R. Second law, the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. This is second law of reflection. So in case of reflection of light, here in this image we can take, this is I, angle of incidence I, and this is the angle of reflection R, and according to the first law of reflection, angle I is equal to angle R. Angle of incidence is equal to angle of reflection, and the second law is the incident ray, reflected ray and the normal at the point of incidence. All this lie in the same plane, isn't it? They all lie in the same plane. This is the second law of reflection. Next, the image is situated on the normal drawn from the object on the mirror, and it is as far behind the mirror as the object is in front of it. Means where will be the image situated if you place an object in front of a mirror? So the image will be situated on the normal drawn from the object. If this is the object, you are drawing a normal to the mirror again, extending from this image only, object only, you are extending the straight line. It means this is the normal drawn from this point, and this will be as far behind the mirror as the object is in front of it. If the object is at 5 meter in front of the mirror, image also will be 5 meter behind the mirror. Okay, if this is 2 centimeter in front of the mirror, behind the mirror image formation also will be 2 centimeter. Okay, so this two distance will be equal. OF will be equal to Fi in this diagram. Actually, this ray, when we take a single incident ray, the ray strikes here in the surface like this, and reflected ray, this dotted line is a reflected ray, and when you extend this dotted line and where this normal drawn from the plane surface of the mirror from the object, where they both meet, that will be the size of an image formed. Okay, so clear? If this is in front of the mirror, if the object is placed at 5 or 6 centimeter, let us take 6 centimeter, object is in front of the mirror, behind the mirror also at 6 centimeter the image will be formed. Okay. Next, on moving to the topic lateral inversion, it means the interchange of the left and right sides in the image of an object in a plane mirror is known as lateral inversion. Even sometime we would have observed that if the pocket in the shirts are in the left side, when we look into the mirror, it seems like as if it is in the right side. When we were small, we would have tried eating in front of the mirror. In the right hand, if we eat, it looks as if we are eating in the left hand. Okay, so this lateral inversion is the interchange of left and right side of the image of an object in the plane mirror. An example we can consider that we would have noticed in our daily life, that on the ambulance, the word ambulance is laterally inverted and printed. It is like this on the ambulance. It's because as the ambulance is on the road moving, the person or the vehicle moving ahead, when they look into the mirror, this laterally inverted words, when they look into the mirror, for this laterally inverted image will be correct form of the ambulance. So the person one who is in the vehicle can read this word laterally inverted ambulance, and then he can give a side to ambulance to pass it first. Okay. Next, we shall see the characteristics image formed by the plane mirror is upright, virtual, same size as the object, and it is laterally inverted, not inverted, laterally inverted. So these are the 4 main characteristics found by the plane mirror. Remember this might be asked for the multiple choice questions. Next, we shall move to the important concept. Based on this concept, there is a question in the model question paper of Gpstr exam 2022. Images formed in 2 inclined mirrors. The number of images formed depend on the angle between the 2 mirrors. If 2 mirrors make an angle theta with each other, the object is placed between the 2 mirrors, then the number of images formed is 360 degree divided by theta. N is equal to number of images formed, N is equal to 360 degree divided by theta. So if the 2 mirrors are at 90 degree angle, substitute the value of 90 degree here and you can calculate. So here the points to be noted are, if N is equal to 360 by theta is odd value, means for the given value of theta, if you calculate the value of N, if you get the odd number is an answer, then the result, the number of images, you have to finalize that further based on these points. It means the number of images is N only, the whatever value you get, that will be the answer if the object is placed asymmetrical, if they mention anything about the asymmetrical object in the question. If they mention anything about the object is symmetrically placed and you got an odd number as an answer here, then you have to subtract 1, N minus 1. Okay, if it is symmetrically placed, N minus 1 from the obtained answer of N. That will be the number of images in that case. But in case of N is equal to 360 by theta is even number, you have to subtract -1 from the obtained answer. Hence, that will be the number of images formed. Okay, let us check it with an example. You will understand in a better way. When two mirrors are kept parallel to each other, that is theta is equal to 0. Parallel means here there is a mirror, here there is a mirror. Opposite, parallel. There is no angle between these two. Theta is equal to 0. Then 360 by theta is equal to 360 by 0, that is infinity. Infinite images will be formed when two mirrors are kept parallel to each other. Suppose if there is an object, image will be formed here, that image will be here, like this. Infinite images will be formed. Okay, remember this. Next, when two mirrors are kept perpendicular to each other, that is theta is equal to 90 degree. One mirror is here, another mirror. Theta is equal to 90 degree. Okay, perpendicular like this. And substitute the value of 90 degree. 360 by 90 give us 4. Hence, the obtained answer is 4. So, it's an even number. So, what we should do to get the final answer? Subtract 1. Number of images formed will be n minus 1, that is 4 minus 1 is equal to 3. 3 images will be formed when two mirrors are kept perpendicular to each other, means at an angle 90 degree. So, you have to obtain by subtracting, and that question was like previous in the question paper, model question paper, it was directly given, that is 360 degree divided by theta minus 1 was the answer for it. Please check it out. We have already solved the question paper. The link will be given in the playlist. Okay. Now let us have a glance of uses of plane mirror. It is used as a looking glass, especially favorite for our ladies. Okay, of course gents too nowadays. Okay, so next one, in optician's room they use plane mirror. In optician's room, to increase the effective length of the room by keeping a plane mirror on the front wall. Suppose if there is a mirror here, front wall, and a signboard on the opposite of the wall. This side opposite to that will be the signboard. The numbers will be, letters will be written there. So that behind the patient, if the patient is here, behind the patient will be the signboard. So that the signboard will be at double length of the room. Okay. This optician's room's mirror we can understand in this image. So imagine this person is standing at 3 meter distance from the eye chart. Mirror is here, opposite to the mirror there is an eye chart, and the distance from the mirror to this person is, let us take 7 meter. Now, where will be the image? What is the total distance of the eye chart from the mirror? 10 centimeter. 3 plus 7 is 10 centimeter. So, where will be the image formed on the mirror? Behind the mirror. Behind the mirror at 10 centimeter. Total image. So, for this person, when he looks at the mirror, so the image would be formed 17 centimeter, 17 meter will be the image distance for this person to see. So, you no need to increase the length of the room by 17 meter. Okay, if the room length is of 10 meter is enough. So, the image will be formed, total image will be at behind this image. So, this is the use of mirror in the optician's room. Even in barber shops, mirrors are used, huge mirrors, and mirrors are also used in periscope, and they have inclined at an angle 45 degree. So, how a periscope looks like this, right? Like this, and the mirror will be placed at 45 degree here and 45 degree angle here, like this it is placed, so that the image will be, object will be reflected here, again it will be reflected and we can see through this, or if the object is placed here, image can be viewed from the other side. We'll take a separate class on periscope only later. And next, mirrors are also used in kaleidoscope. The angle between the mirror is 60 degree. The three mirrors are placed like this between 60 degree angle. So, it is a, what type of triangle it is? Equilateral triangle. Yes. Even mirrors are used in solar heating devices to reflect the light rays incident from the sun on the substance to be heated up. Okay, in solar panels they use mirrors to reflect the light ray and to be getting heated up. Okay, so these are the important points we have covered from the optics. I too read a few comments saying that the images are blur and it's not clear. So actually I record the video of high resolution only 108p. If the network is slow, at starting point you may get the blur image. You just wait for a few seconds and then it will be clear. Or if your video quality you have set automatically for less than the 1080p quality resolution, it will be little blur. Please change your video quality to get this clear image of the video. Okay, so thank you for your valuable comments. So keep preparing for the exam. In the following classes we will cover up remaining subtopics from physics. I'll go with a little physics and maths, then we'll take up little biology also in between. You can learn the easy topics from the biology, you can cover up. Very little difficult topics, I'll try to cover up the important points from the topics. Okay, thank you for your support. Thank you for watching this video. If you like this video, don't forget to give a thumbs up.